Now let's take a look at the different types of force fields. Force is the most basic of them all. Positive strength pushes things away from it, and a negative value will pull things towards it at a constant rate. Wind is similar to a force, but it pushes or pulls in a single direction instead of a point in space. A vortex will spin the particles around the local z-axis of the force field. Positive strength will push the particles away as they spin, and a negative strength will pull them in. A magnetic field will simulate magnetic attraction between particles or objects. This one is interesting because the movement it causes is determined by the velocity of the particles once they're in motion. You can see that the pattern of movement changes depending on the direction and speed they're going. A higher strength value will move the particles through the same pattern, but a little bit faster. The harmonic field makes the objects or particles it affects like pendulums that move towards the center of the field and then back to their original location, and then bounce back and forth in between. The rest length controls how far away from the center of the field the particles consider to be the goal. The damping value sets how much energy the particles lose with each bounce. The charge field only works when you assign it to a particle system as well as an object. The strength value is how charged the particle is. Just like with magnets, but unlike dating, two positives will repel each other, but a positive and a negative will attract each other. The Lennard-Jones force field only works with really densely packed particles, so for this example I increased the size to be really big, but I'm only displaying them as little circles so you can see what's going on really clearly. If the particles are far away from each other, they will be attracted to the field, but the more densely they are packed, the more that they will be repelled. A texture force field uses a 2D image to manipulate the particles. Here I'm using a gradient texture to shove the particles to the side. The size of the texture depends on the size of the force field. A curve guide only works when applied to a curve, and it creates a force field along its length relative to the position of the particles. The particles take their whole life to reach the end, so the shorter the lifetime, the faster they will follow the curve. There is a Boyd's force field, but it seems to have lost all purpose when Boyd's became their own type of particle system, which is a topic for another time. Suffice to say, this field really does nothing anymore. The turbulence field creates a randomized 3D noise pattern for the particles to follow. The larger the size, the larger and more defined the noise pattern will be. A drag field slows down speeding particles or objects. The linear drag setting slows down the particles evenly over time, and the quadratic setting slows down the particles proportional to the square of their velocity. Lastly, we have a smoke flow field which can be applied to a smoke domain. It allows the smoke itself to push around objects and particles that it comes in contact with. So that's all the different types of force fields. They're a lot of fun to play around with once you get the hang of how they work, so I'd recommend testing out a few of them and seeing what they do.